Do a little review of scientific notation. The definition of scientific notation is that it's a number written as a product of a coefficient and a 10 raised to a power. And that coefficient has to be a number between 1 and 10. So what does that actually mean? Basically, you have some number that we'd fill into this box. You multiply it by 10, and that 10 is raised to some power. So the coefficient has to be a number between 1 and 10. So this number right here in the front has to be between 1 and 10. It cannot be smaller than 0, so it can't be negative, and it cannot be a number larger than 10. And really, you don't even want it to be 10. So it should be like 9.99999 at the biggest. Some examples of numbers written in scientific notation would be like 6.5 times 10 to the negative third, or 2.1 times 10 to the 15th power. A number like 10.7 times 10 to the third power is not scientific notation, and the reason for that is we can't have that number, the coefficient, be between or be any larger than 10. So what do those exponents mean? Well, if a number, when it's written in standard notation, and standard notation is writing like 4,000, if a number in standard notation is larger than 10, the exponent's going to be a positive number. An example of this is if I had the number 3,500. So 3,500 is my number in standard notation. If I want to put it into scientific notation, I'm going to have to write it as a coefficient between 1 and 10 times times 10 to a power, and that power is equal to basically how many places I move the decimal. So to get this to be a number between 1 and 10, I'm going to move my decimal from here at the end, even though it's not written, that's where we understand it is. 1, 2, 3 places, so it's going to end up between the 3 and the 5. So 3.5 times 10 to a power, and that power is the same number of places that I move my decimal. In this case, it's going to be a positive number because the number in standard notation is a big number. It's bigger than 10. Now, if I have a number in standard notation that's smaller than 1, my exponent has to be negative. So an example of that, if I have a number like 0.00079, this is smaller than 1. It's a decimal. That's what it means to be smaller than 1. I have to put the number in, make a coefficient that's between 1 and 10. So I'm going to move my decimal from where it is right here, 1, 2, 3, 4 places to make it 7.9 times 10 to some power. Remember, I moved it 4 places, and it's negative because my number in standard notation is smaller than 1. All right, that's really important to remember. If your number is small, a negative exponent. If your number is big, it's a positive exponent. All right, here's some sample problems. Go ahead and try putting these into scientific notation. If you want to press pause and then press play, I will give you the answer to each one. Okay, so here we go. The first one we have is 23,000. I'm going to write 2.3 times 10 to the 1, 2, 3, 4th power, because I moved the decimal 4 places to get it between the 2 and 3. Now it's a positive 4 because this number is larger than 10 in standard notation. All right, next one. 9.23 times 10 to the 1, 2, positive 2 power, because again, this is a number larger than 10. All right, next one. In order to get the coefficient to be a number between 1 and 10, I'm going to have to move the decimal 1, 2, 3 places to make it 3.75 times 10 to the, this time it's negative 3 power, because this number in standard notation is smaller than 1. All right, and then the last one is going to be 5.6 times 10 to the negative 1 power. And again, it's negative because that number in standard notation is smaller than 1. All right, let's try some going from scientific notation to standard notation. So the best advice I can give you is that first thing you should do is look at the exponent after the 10 and decide, is this number going to be smaller than 1 or larger than 10? So for this first example, the exponent is -5. So that means it's going to be a number smaller than 10 when we write it in standard notation. So I'm going to move the decimal to the left to make this number small 5 times. So I have 2.56. If I move the decimal 1, 2, 3, 4, 5 places, I'm going to have to fill those places with zeros. So I have 4 zeros in front of the 2. So when I write that, I'm going to end up with 0.1234 and then 256. So this would be your answer in standard notation. And as you can see, writing that is kind of a lot of zeros. So it's better to write it in scientific notation for a lot of reasons. It's easier to read, it's easier to write, things like that. All right, let's do another one. This time we have a number that has a positive exponent, positive 8. So when we write the 3.45, we're going to be moving the decimal to the right 8 places so we can make it a number bigger than 10 in standard notation. So we've gone 2, 3, 4, 5, 6, 7, 8 places. Fill in those zeros, and we should end up with 3, 4, 5, and then 1, 2, 3, 4, 5, 6 zeros. So this is our number in standard notation. Again, pretty big number, lots of zeros, long to write. All right, let's try one more. The next one, 1.23 times 10 to the negative third. So think about is this going to be a big number or a small number? Hopefully you decide it's going to be a small number. We're going to move the decimal to the left 3 places. So we're going to end up with 0 point, and move it 1, 2, 3 places. I'm going to have to fill in 1, 2 zeros before the 1, 2, 3. So there's my number in standard notation.